Bulmana, welcome back to our next phase of solving mathematics problem. Today we will be moving on to our second part of solving complex numbers. Let's have a look at some questions on complex numbers. This time around we'll be moving down into solving and looking at more questions in complex numbers. Let's have a look at some examples. Okay, in our last class we were solving purely 2024 paper. Complex numbers is 13 marks. We'll look at question number one. Question number one is just an overview of what we have already discussed. Question number one, we've solved it in our first lesson. A, B, C, D, E, F. We'll start with F today. Okay. We have completed E. Today we will start with F. And yes, we'll start with F today. So let's have a look at the second phase of solving complex numbers. That is this question. So let's have a look at this question. That is F in 2024 paper. I'll just write down the question. So this is F under the complex of complex numbers. So this is 2 C is 30 degrees to the power of 6. The question is saying leave our answer in polar form. Okay, let's try and answer that. So our question is saying that we need to solve this, or we need to find what is the value of 2 C is 30 to the power of 6. And whatever answer we have, we need to leave our answer as polar form. Okay. So what's the approach here? Now the approach here is when a function, this is in polar form, when a complex number is given to you in polar form, and when this polar form is raised to the power, any power, then I will rewrite this equation in the form of this, in polar form. So polar, we have looked at it in our previous video, that for any polar form we have an equation written as R C is theta, but in our case this is the power of n. Now when a situation that you come across like this obeys what we call DeMoivre's theorem. DeMoivre's theorem says that for any complex number raised to the power of n that is equal to, we'll raise this power to r according to DeMoivre's theorem. According to DeMoivre's theorem, we'll raise this power to r, that is r to the power of n, sees this n is multiplied to theta. So that would be theta times n. This is what we call DeMoivre's theorem. According to the theorem, DeMoivre's theorem, that's what we're going to do if we come across situations like this. Yeah? Now let's solve them. So since this equation, or this complex number, is raised to the power of 6, then we'll obey the DeMoivre's theorem, because DeMoivre's theorem says any complex number is raised to the power of n, we will raise n to r and multiply n with theta. So I'll rewrite this as 2 sees theta to the power of 6, and theta in our case is 2, sees 30 degrees to the power of 6. Now what is r? R in our case is 2, and theta in our case is 30 degrees. So let's try and solve them. So this is 6 to the power of 2. Many students do this mistake in the exam. They forget to write down the formula. Formula is like your map. So that's theta. Our theta in our case is 30 degrees times 6. So what is 2 to the power of 6? Now let's try and find that in our calculator. So 2 to the power, our power sign, 6 is what? 64. So our answer here is 64 sees 30 times 6. So let's press 30 times 6 will give us 180 degrees, and this is our answer. Why? Because according to the question we need to leave our answer in polar form, and this is in polar form. But in some questions, when they don't mention polar form, take this out. If they just give you this question, and they say, okay, simplify 2 sees 30 to the power of 6. If they don't mention about polar form, that means we need to leave our answer in rectangular form, depending on the questions they ask you. For this question, they had asked you to leave our answer in polar form, and this is our polar form. But let's say if polar form is not there, that means we need to convert this in rectangular form. And how can we convert it? Like I've mentioned you in our last video, how to convert polar into rectangular and how to convert rectangular into polar. Let's have a look at one. Let's convert this into rectangular. Might in any case they ask us to leave our answer in rectangular form. Okay, for this case I don't know where's the polar in this calculator. I'll use this one here instead. Okay, how can I press polar? Pole, I think all of you have noticed that this is pole. Okay, I'll just zoom the camera for now. Okay, pole is here. This is pole. This button here is pole, and on top is what we call rec, and this is pole. So if you want to convert any rectangular into polar, we said pole, that is in polar form. But if you want to convert a polar form into a rectangular form, then rectangular, it's yellow, we press shift and polar, it will give you rec represents rectangular form. Okay, so let's convert using that principle. So let's convert this value into rectangular. If in case they don't mention in polar form, it's very particular. You need to be very particular on the question. Now if the question is saying in polar form, then we need to leave our answer as that is our answer. But if it's not asked in polar form, then we need to convert this into rectangular. And how can we convert it? We press shift, pole will give you rec, and then whatever value you see first, 64, so 64, comma, and whatever value comes second is 180, and close the bracket, equals. That gives us minus 64. So our answer in this case is minus 64. So this is minus 64, that will represent our real value, because we're converting polar into rectangular. So rectangular has real and an imaginary. So this is our real value. So I want to find my imaginary. Same concept that I showed you in our last video. You press recall. Recall is above 7. This is recall. So recall tangent. Press recall tangent. That gives you 0. So this is plus 0i. Okay, I can simplify this as saying it's just 64. So this is my answer in rectangular form. This is my answer in rectangular form. This is my answer in polar. Okay, let's check if this is rectangular. Let's go back and check if this is our polar form of this, or this is the rectangular form of this. Let's check. Convert this rectangular back to polar. Okay, so that means we press this is our rectangular, whatever comes first. So we say pole. This is my red pen. Okay, pole, press pole. Whatever value comes here, whatever value first comes minus 64, so this is minus 64, comma, and whatever value is here, if it's positive, if it's negative, you press it, or in our case it's 0, so we press 0, close the bracket, equals, this is our R, because in polar, R comes first, then theta. So whatever comes first is your R. So in our case is 64. C is, you want to find your angle. Angle is recall, same process, recall tangent, and our angle is 180 degrees. Does it come back here? Yes. So that means this is our rectangular form. We can use this concept in converting either polar to rectangular or in rectangular to polar. We'll use the same concept here. Okay? Alright, I want you to use the same concept. Try this out. Try this as your exercise. Let's say convert 4 sees 60 to the power of 2. Try that out. You can pause the video and answer that question. So this is 4 sees 60 to the power of 2. You can pause the video and answer that. I give you 2 minutes using the same concept, and your 2 minutes starts now. Okay, let's try that out. So let's identify, this is our R, so this is R sees theta to the power of 2. Remember, whenever it's power, we will use DeMoivre's theorem, and this is DeMoivre's theorem. So since this is to the power of 2, the question is saying simplify. Okay, once we go in, then I will tell you the difference between simplify and solve. This is simplify. Whenever we simplify, we use DeMoivre's theorem. Whenever we solve, we will use another approach called finding the nth root. We'll look at it inside. I want you to know the difference. Now, when there are 2 there, so this is R sees theta to the power of 2. Simplify, then we'll use DeMoivre's theorem. Look at the keywords. So that's DeMoivre's theorem. So DeMoivre's theorem says R2 sees theta times 2. So R in our case is 4. So 4 squared sees 60 times 2. And this is 16 sees 60 times 2 is 120 degrees. This is our answer if the question is saying leave your answer in polar form. But if it's not asked, then we need to convert this into rectangular form. Yeah? Okay, let's move on to our next question. Okay, question 2, simplify. Question 2 says simplify 5 over 2 plus I. Okay, let's try and solve that out. Okay, 5 divided by 2 plus I. Now, before we answer that, in our previous video, I was defining what is I. I is square root of -1. Yeah? And also we saw that I squared, this I squared is the same as A squared. A squared means A times A. So I squared is equal to, I is root of -1, so this is square root of -1 squared. And we know that squared and square root, they are opposite, they cancel out. So we left it I squared is equals to -1. We'll use this inside. Okay, now let's use this inside. Now, whenever we come across this kind of equation, now over here we say that this is plus 0i, yeah, because there's no imaginary, we say that's plus 0i, or we can cancel out. But at the back of our mind, this is not a whole number, like 5 divided by 2 plus I. This 5 is a complex number where I is 0, just like we did here. I is 0, yeah. So in this case, I is 0, so we don't write I, but actually it's a complex number where I imaginary is 0. Okay, let's try and solve that out. So whenever we come across equations like this, so 5 over 2 plus I want to solve this. A complex equation divided by a complex equation or complex function. What we do is we multiply the denominator with the conjugate. Conjugate, I've explained it in our last video, that whenever you stand in the mirror, whenever you lift up your right hand, the image is lifting the left hand. So the image is the opposite of you, or the conjugate of you. So this is you, 2 and I, but the thing is that when you lift up your right hand, the image is lifting the left hand. So if this is positive, then that is negative. So whenever you multiply anything on the denominator, you multiply it also in the numerator. And what do you understand about fraction times a fraction? So A over B times C over D. Whenever we multiply fraction, we multiply numerator times numerator, denominator times denominator. So this is AC over BD. We use that concept here. So this is 5 into 2 minus I, always use bracket, over 2 plus I into 2 minus I. Now once you get here, all the rest is all algebra. So let's open the bracket. Whenever we open the bracket, every term goes to each of the term, meaning we'll use distributive law. This one goes there, this one goes there. So in distributive law, whenever we open the bracket, we'll use this sign. Keep that in mind. We'll use the sign. Sign meaning positive times positive will give you a positive. Negative times a negative will give you a positive. But the difference is when I multiply the two. Positive times a negative will give me a negative. This is a very important law. We'll use this here. Okay, so let's use it there. So let's go. This is whenever we open the bracket, we multiply. So 5 times 2 is 10. positive, there's a sign here. I want to go to I, but before I go to I, I'll go through the sign. So this is positive times a negative. Positive times a negative will give me a negative. 5 times I is 5I. Divide by, this one goes here. 2 times 2 is 4. This one goes here, but before it goes here, it'll go through the sign. So the sign here is positive. So positive times negative is positive times negative is negative. 2 times I is 2I. Goes here, open the bracket. Positive times positive is positive. I times 2 is 2I. This one goes here. Before it goes to I, it will go through the sign. So positive times negative is negative. And I times I, what is I times I? Is I squared. Yeah, because I times I is I squared. Now, once you get there, all the rest is all algebra. Let's simplify. The numerator remains the same because we cannot add or subtract them because they are unlike terms. So this is 10 minus 5I over 4. You will notice that this is negative 2 apple plus 2 apple. They are like terms, I can add them. So minus 2 apple plus 2 apple. Minus 2 plus 2. You go to minus 2 plus 2, go up 2 times. It will give you 0. So they cancel out. So you're left with minus I squared. Let's further simplify. So this is 10 minus 5I over 4 minus, and what is I squared? I squared is negative 1. So we put negative 1. Always use bracket. Many students, they think that this negative 1 is for this minus 1. They know for sure that I squared is negative 1. But when they come to the next step, they think that this negative 1 is already this minus sign. This is where they get penalized. Always be very careful in solving mathematical problems. So in our case, negative is negative. This I squared is negative 1. This is negative 1. Always use bracket. Now let's further simplify. So 10 minus 5I over 4. Negative times a negative. Negative times a negative will give me a positive. So this is positive 1. So this is 10 minus 5I over 4 plus 1 is 5. I'll try and put it here. So this is 10 minus 5I over 5. Now can I further simplify? Yes, I can break this down using the concept of adding and subtracting fraction. We say that A over B minus C over B, we can only minus or plus a fraction if and only if they have the same denominator. In this case, they have the same denominator. So since they have the same denominator, I can minus the numerator, A minus C. I'll repeat that again. I can only add or subtract any fraction if they have the same denominator. So in our case, they have the same denominator, I'll consider the numerator. I can either go from here to here. In this case, it's written like this. So I can separate this as this. So 10 divided by 5, this minus sign remains, and 5I over 5. Because they have the same denominator, let's get you back here. So let's further simplify. Can 5 go to 10? Yes. How many times? 2. So this is 1 and this is 2. So we have 2 minus 5. Many students think that this is right. When 5 plus I over 5, they cancel it out. No. Many students think like this. 5 plus I over 5. They cancel this out. This is wrong. We cannot cancel if they are added and divided. We can only cancel if they are multiplied and divided at the same time. Now in our case, remember I told you in our last video, when two things are together in mathematics, AB is the same as A times B. Similarly here, when two things are together in mathematics, they are multiplied. So in our case, they are multiplied at the same time divided. I can cancel them out. So you left it I. So this is your answer. Yeah? So your answer in this case is 2 minus I. I hope that that you understand that part. Let's answer. Use the same concept. Try this out. Simplify 3 over 2 plus I. 2 minutes. Concept is the same. Answer that using the same concept. You can pause the video and answer it too. Give it 2 minutes. Okay, let's try and solve that. Since this is a complex function over a complex function and it's divided, then I will multiply it with the conjugate. So this is 2i. Since this is plus, then I'll put minus. I'll do the same as our enumerator. Now since they have a fraction plus times a fraction, we multiply straight. So this is 3 into 2 minus I over 2 plus I into 2 minus I. Next is opening the bracket. So this is 3 times 2 is 6. Positive times negative. Positive times negative is negative. 3 times I is 3i over 2 times 2 is 4. Positive times negative is negative. 2 times I is 2i. This one goes here. Positive times positive is positive. I times 2 is 2i. This one goes here. Negative positive times negative is negative. I times I is I squared. Let's further simplify. So 6 minus 3i. I cannot subtract them or add them because they are unlike terms. This is apple, this is orange. I cannot add or subtract apple and orange, so they remain the same. This is 4 remains. You'll notice that these two cancels out. You left with minus I squared. So you left with 6 minus 3i over 4 minus I squared is negative 1. So this is negative 1. So you left with 6 minus 3i over 4. Negative negative is positive 1. So we left with 6 minus 3i over 5. You can either want to separate it. You can separate it as 6 over 5. Negative remains. If it's positive, this is positive. 3i over 5. That's your answer. Any questions? Okay, let's move on to our next question. Okay, sketching of argan diagram. Okay, I'll just change our place here. Okay, sketching of argan diagram. Okay, now let's sketch. The question is saying sketch imaginary of z is equals to 2 on an argan diagram. Okay, let's sketch that. Now whenever we sketch, I have showed you in our last video, in our last class, in sketching a complex functions in an argan diagram. Suppose, okay, let's answer this. So let's sketch this. This is our real, and this is our imaginary, and this is our zero mark. this is our imaginary of z. So this is our imaginary of z. We need to sketch imaginary equal to 2. Imaginary is just like our y value. It's just like y equal to 2. How can we sketch y equal to 2? We go along the y value. Where is 2? This is 1, 2, 3, 4, negative 1, negative 2, negative 3, 1, 2, 3, 4, 1, 2, 3, 4. Imaginary of z, we look at the y value. Where is 2 along the imaginary of z? Here. You just take your ruler and join it. This is what we call the imaginary of z equal to 2. Yeah? If it was a real of z equal to 3, then I'll go to my real value. Where's 3? So 1, 2, 3, 4, negative 1, negative 2, negative 3, and negative 4. I'll go to my real value. Where is 3? This is 3. I will join a line like that. So this is what we call the real z equal to 3. But in other case, if they give you a complex equation, let's say z is equals to, let's say, 3 plus 4i, and they ask us to sketch this. So we can sketch it like this. Oh, my pen is giving up on me. How can we sketch it? So this is our real, this is our imaginary, and that's our 0 mark. So 3 is 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 1, 2. Okay, 3. So this is 3 along my real. This is my real value. This is my imaginary. Where's my imaginary? This is my imaginary, and this is always I under the complex plane or argan diagram. So 3. This is 3 along the real value, and 4 because I is already here. So 4. 1, 2, 3, 4. So where do they meet? They meet along here. So this is your value of z is equals to 3 plus 4i. Okay, so that's how you sketch your complex equation into a argan diagram, and this is what we call the angle theta. Okay, that's how we convert into polar form. I've showed you in our last lesson. Let's move on to our next question. Okay, in our last question is solving. Like I told you in our last class, whenever we come across solving a function, okay, I'll just take this off, get more paper. Okay, whenever we are coming across solving, look at the very word solve. I told you when they say simplify, even though it's z to the power of 4. So this is z to the power of 4 is equals to 16 cos of 120 degrees plus I sine of 120 degrees. And the question is saying leave your answers in polar form. The question there is saying solve. The question here is saying solve. Now when it comes to solve, even though this z is to the power of 4, if this was simplified, z to the power of 4 will use DeMoivre's theorem. But in this case, it's not saying simplify, it's saying solve. So whenever we are solving, we will use the nth root. Let's have a look at some problems to it. Now the question is saying solve, meaning we need to find the nth root. So the nth root, the formula for the nth root or finding the root, we only find the root if the question is saying solve. Now how can we find the root? So finding the nth root, the general formula is, this formula will be given in the exam, r 1 over n. Okay, I've showed you in our last class, when it's written like this, cos 120 I sine 120, I can rewrite this. Hang on, I can rewrite this as saying 16 C's 120 degrees. This C's is a simplified version of cos 120 plus I sine 120. Cos and sine, the simplified version, we write it as C's. I've explained it in our last video. So I can rewrite this as 16 C's 120, and this is written in the form of R C's theta. Okay, so let's go. We are solving, so we need to find the nth root. So the root formula is R 1 over n. What's the formula? Over C's theta plus 360 k over n. This is our formula. So this formula, we need to write this formula in the exam. It's very important. What is our n? What is our theta? What is our k? Okay. First, we need to look at what is our n. Our n in this case is 4. This is z to the power of n. N is 4. So whenever you know your n is 4, automatically you know your k value. K will be determined from n. So if n is 4, then we'll look at our numbers starting from 0, 1, 2, and 3. We'll not go to 4. So our k value is 0, 1, 2, and 3. If n is 3, then our k value is 0, 1, and 2. Yeah? So why? This is n equal to 4. Our k is 0, 1, 2, and 3. We have one term, second term, third term, and fourth term. Always start with 0. So we have a fourth term because n is equal to 4. N is equal to 3. We should have 3 terms, but starting from 0. 1, 2, and 3. I think you get the part, the sequence. So n is equal to 4. K is equal to 0, 1, 2. What else? R. Our R value is 16. And our theta is 120. Once you know this, once you're able to determine your values of n, k, r, and theta, you're able to answer that question. So, first of all, let's say we're finding k. Start with k equal to 0. So k equal to 0, start from here. So we'll say r is equals to, what is our r? R in our case is 16, so we'll set 16, 1 over n in our case is 4, into c's theta is 120 plus 360. What is k? K is 0, so 0 over, what is n? N is 4. Okay, what is 16 to the power of 1/4? Okay, I want you to press this in your calculator. In your calculator. Okay, 16. I want you to press this in your calculator. Okay. Okay, 16 to the power of 4. So 16. Oh, sorry. Okay, I think you can see that. Okay, yes. Okay, let's try and press this in your computer. This is 16 because our R here is 16, so this is 16. 16 to the power of 4, or 1/4, sorry. So 16 to the power, this is your power, of 1/4. 1/4, always use bracket. Bracket, always use bracket. 1 divided by 4, close bracket, equals 2. So our value here is 2. So So this is 2 C's. Okay, if I were you, I would solve this first, answer, then divide by 4. Okay, so this is 120 plus 360 times 0. I'll multiply these two first, answer added with 120 equals, then divide by 4. So 0 times 360, anything times 0 is 0, so I left with 120 divided by 4, and that is equal to 2 C's. 120 divided by 4 is what? So let's press in a calculator. 120 divided by 4. So 120 divided by 4 equals 30. So answer here is 30 degrees. Okay, this is when our K is 0, or when we say WK is 0. So let's try WK when equal to 1. So remember, we're trying to solve, we start with K 0, let's go to 1. So when K equal to 1, so we know that this value will always be 2, because it will repeat, because this formula will be repeat, but K, this formula will be repeat, but the K will be different. It will start with 0, 1, 2, and 3. It will repeat. This is the first root, second root, third root, and fourth root. That's what it means. So we need to first find the first root. This is the first root when K is equal to 0. Now we're going to look at K when equal to 1 using the same formula. So if we're using the same formula, this value will remain the same. So in our case, we have found, and it's 2. So let's go. So let's try and solve that. So this is 2 C's. Theta is 120, so 120 plus 360. In this time around, our K is 1. So 1 over 4. What is that equal to? So let's try and solve this. So we'll say that 360, so I'll say 2 C's. 360 times 1 is 360. 360 plus 12. So I'll say 360 plus 120 equals 480. So 480 is this value divided by 4. Divide by 4 equals 120. So this is 120 degrees. So my WK1 equal to 1 is 120. Okay, this is my second root, first root, second root. Let's look at the third root. Let's look at the third root. So our third root here is WK equal to 2. So this is 2 C's 120 plus 360. This time around, instead of 1, my K is 2. Divide by 4. So what's your answer? Same case. So I'll multiply this first, answer, then added with 120 equals, then divided by 4. So I'll say 360 times 2, so 360 times 2 equals 720 plus 120, so plus 120 equals 840 divided by 4, divided by 4 equals, so this is 2 C's 210 degrees. So this is K equal to 2. This is the third root. Let's look at the fourth root. K is equal to 3. Concept is the same. Let's look at the fourth root. So this is 2 C's 120 plus 360 into 3. Because K 2, this time it's 3 divided by 4. This is 2 C's Okay, what is your answer in this case? So what is 360 times 3? Concept is the same. So 360 times 3 equals, that is this value multiplied by, plus it with 120 equals, and divided by 4 equals 300. So our answer here is 2 sec theta into 300 degrees. This is WK equal to 3. Now, this is your answer. Why? Because the question is saying leave your answer in polar form. This is our answer in polar form. So we can say that, therefore, our K equal to 0, you can say, therefore, in your next line, our K equal to 0 is this, 2 sec 30 degrees, or I can say here, I'll get another full step. So I can say here is, I can say that therefore our K0 is equals to 2 sec 30 degrees. Our K1 is 2 sec 120 degrees. Our K equal to 2 is 2 sec 210 degrees, and our fourth root is 2 sec 300. And this is our answer in polar form. If it's not written in polar form, then we need to convert this to rectangular using the concept of the technique that I've showed you earlier. And that brings us to the end of our work today, and we will use the same concept in answering your assignment. We'll stop over there. If you have any questions, please you can send me an email, or you can drop me a message on our Google Class so that we can communicate there. I hope that you get the concept, and hope that you can use this concept in answering your assignment. This brings us to the end of our topic called complex number. Let's stop over there.